Hello, so today's lesson, what we're going to do is we're going to look at the atom and the periodic table. Now, me personally, I find this subject area to learn about extremely interesting because it allows us to understand how everything around us is made up. Now, first of all, if we think about the atom, let's think about how small an atom is. Now, what I've got here and what I've put on the board here is a 50p piece. Now, in this 50p piece, atoms are so tiny, there are millions and millions and millions of atoms that are making up this 50p coin here. Okay, so if we're thinking about the size of an atom then, so if we're thinking about the atom and we're thinking about the size, one atom, the radius, so if we think about an atom from this end to this end, the radius of one atom is approximately 0.1 nanometers. Okay, now you might be thinking, I don't know what a nanometer is, but you would know what a meter is. So if we think about it in terms of a meter, that would be 1 times 10 to the minus 10 meters across. So that is extremely, extremely small. Now, when we think about an atom, there are different parts of the atom that it is important for us to know about. So these different parts of the atom are called subatomic particles. So the first thing that we are going to look at is we have inside the atom, we have these subatomic particles that are called protons. Okay, now protons are the subatomic particles which are positively charged. So protons have a positive charge on them. Now, in terms of subatomic particles and the things that make up an atom, because remember we said in the 50p piece there were millions and millions and millions of atoms, we can't possibly measure the mass of one atom. But what we do is we compare the size of particles in the atom to each other. So what we say is, we say that the proton has a relative mass, okay, so a relative mass of 1. So what we will then do is when we look at the mass of the other subatomic particles, we will do them as a comparison to the proton. So if a proton we say is 1, then what we will do is we will compare what the mass of the other particles would be relative to a proton. Okay, so that's one of the type of particles that we have. And then we have these other type of particles, which I'm going to draw in now. And these other type of particles here are called neutrons. Okay, now neutrons are not positive and they're not negative. Okay, so neutrons are neutral. So we say they have 0 charge. They're not positive and they're not negative. Now, neutrons are relatively a similar size to the protons. So if protons have a relative mass of 1, then the neutrons have a relative mass of 1. So I'll put that 1 there. Okay, so they're quite a similar size, protons and the neutrons. Now, these two types of subatomic particles are contained in the middle part of the atom, and the middle part of the atom is called the nucleus. Oh, that colour's not working. Just get a different one. Let's go with green. Okay, so we are looking at the nucleus. Now, the nucleus therefore contains, actually that's not showing up, I'm just going to do that in the black pen. There we go. Okay, so the nucleus contains the protons and the neutrons. Protons, positive charge, mass of 1. Neutrons, 0 charge, not positive, not negative, and a mass of 1. Then what we have is the third subatomic particle. And the third subatomic particle is the electron. So what I'm going to do here is I'm going to draw these circles. Now the reason I'm drawing these circles is because electrons don't go anywhere. Electrons go on these circles, which are known as either electron shells or sometimes we call them energy levels. Okay, so I'm going to draw my electrons as crosses. Now you can draw them as circles, but just to make sure that we understand what the different parts are, I'm drawing them as crosses today. Okay, now with the electrons, when we look at the electrons have a negative charge. Okay, so I'm going to put minus there. So electrons have a negative charge. Now, in comparison, so this isn't drawn to scale, but in comparison, the electrons are tiny compared to the protons and the neutrons. Okay, so if the protons and the neutrons have a mass of 1, then the electrons are so small that their mass is 0.0005, or sometimes is written as 1/2000, but sometimes, because it's so small, 0.0005, quite often it's just rounded up to 0. Okay, so those are the 3 subatomic particles that make up the atom. Now, what I would suggest that you do is, as we're going through this lesson, it would be good maybe if you had a piece of pen and paper and took some notes. So if you wanted to go back over them and just recap on a few things, you'd be able to do that. So the key thing that we're coming here to start with is nucleus has the protons and the neutrons in there. Protons have a positive charge, neutrons have a 0 charge, protons have a mass of 1, neutrons have a mass of 1. And then the third type of subatomic particles sit on the energy levels or the energy shells. They are the electrons, and that's what has negative charge. And they are tiny compared to these subatomic particles. So their mass is 0.0005, or quite often we just round it up to 0. Now, the other thing that we need to understand is that because we've got these particles in the middle here, okay, and I'm just going to, I think these have got a bit close together, so I'm just going to move this down a bit so we don't get confused. Okay, so because we have the positive subatomic particles in the nucleus, and we have the neutrons which don't have a charge, okay, what that means is overall the nucleus has a positive charge, because that positive charge gets spread all around the nucleus. So overall the nucleus is positive because it has the positive protons in there, and then the electrons are orbiting in these energy levels, energy shells around the nucleus. Now, when we start to think about an atom, okay, if we look here on this diagram of the atom, I have drawn on here, now this is going to these not coloured circles here, okay, I have 1, 2, 3 protons in the nucleus. Now, an atom always has the same number of protons as electrons. So if I've got 3 protons in my atom, I will always have 3 electrons on my electron shells. Okay, so atoms have the same number of protons as electrons. Now, what I'm going to do now is I'm just going to rub this off. So hopefully you would have taken some notes and drawn this diagram. And what I'm going to ask you to do now is, with the information that I'm going to put on now, I'm going to put, for my atoms, my different atoms, I'm going to write how many protons we have, and then if you can work out how many electrons we have. So, for example, if I have an atom of nitrogen, so let's do this for, so write substance. If we write the number of protons and then the number of electrons. Now, I'm not going to include the neutrons because the neutrons don't have a charge. So, first of all, if I'm looking at nitrogen, an atom of nitrogen, I know that an atom of nitrogen has 7 protons. So that's going to be 7 positive subatomic particles in the nucleus. Then, if I look at an atom of oxygen, oxygen has 8 protons, so that's altogether 8 positive subatomic particles in the nucleus. And then, if I have rubidium, rubidium has 37 protons, so that's 37 positive subatomic particles in the nucleus. Now, I'm going to give you a minute, and I would like you just to think about how many electrons each of these have. Okay? And once you've done that, have a think about, what do you think is the overall charge on an atom? Okay, so the key thing was, remember we said in an atom you have the same number of protons and electrons. So if I know that my nitrogen has 7 protons, then it will have 7 electrons, so that's a charge of -7. If my oxygen has 8 protons, it will have 8 electrons, so that's an overall charge of 8 negative subatomic particles, so that would be -8. And then with rubidium, rubidium's got 37 positive protons, which means it's going to have 37 negative electrons. They have to be the same in an atom, so that's -37. Now, the key thing here now is, what do we think the overall charge on an atom is going to be? Now, the neutrons have no charge, so we don't really need to think about the neutrons in terms of the overall charge because they don't contribute. They're not positive, they're not negative. But the protons and electrons are. Now, if we look at our nitrogen, if I have 7 positive protons and 7 negative electrons, that's +7 and -7, the overall charge here is 0. Because my 7 positives are cancelled out with my 7 negatives. If I look at my oxygen, I've got 8 positive subatomic particles. I've got 8 negative subatomic particles. So my +8 and my -8 cancel each other out. The protons and electrons are the same, so they cancel each other out again, and we have 0 charge again. And then the same goes for the rubidium. Okay, now what that means is, does not matter which atom we're looking at. could be any atom on the periodic table of any element. Okay, atoms always have the same number of positive protons and negative electrons, which means the overall charge on an atom is always 0. Okay, now this here, if you're watching this video and you've started your GCSE learning, this question sometimes comes up. What is the overall charge on an atom? Okay, and depending on how many marks it is, the simple answer is the overall charge on an atom is 0. And if you want to get those extra marks, you say because atoms have the same number of positive protons as negative electrons. Okay, lovely. Okay, so we know the basics then about the atom. Now, the beauty to do with the atom is that not only does it come up in chemistry, but it also comes up in physics. So if we know the structure of the atom properly for chemistry, we will also know it if it comes up for physics. So to summarise the properties of the atom and the subatomic particles, so first of all, we will write down here the subatomic particles that we have. So we have the proton, neutron, and the electron. Okay, so those are the 3 subatomic particles that make up an atom. Now, then we have the relative atomic mass. Now, sometimes you'll see it written in this way for short, relative atomic mass. And the relative atomic mass of a proton, we said, was 1. So that's one of the larger parts of the atom. The neutron is a similar size to the proton. So the neutron also has a relative atomic mass of 1. And then the electron is the particle that is tiny compared to the other parts. So the size is 0.0005, or we could round that up to 0 or say it's negligible. Okay, negligible meaning it's so small that it doesn't really count when we're considering it. Okay, now in terms of the charge, when we're looking at the charge, okay, we have the charge of a proton, which is +1. So one proton has a charge of +1. Neutron, we said, did not have a charge. So it's 0, it's not positive, it's not negative. And an electron has a charge of -1. And we always got to remember that in an atom, there is always the same number of electrons as there are protons. And then lastly, where are these subatomic particles? So the proton is in the nucleus. So that's in the center of an atom. The neutron is located in the nucleus, again, the center of the atom. And electrons are on the energy levels, which are the circles orbiting the nucleus, or we can say are on the electron shells, whichever you prefer. Okay, so that's a summary of the atom. Now, what we're going to do now is we're going to have a look at different atoms in a little bit more depth and just try and understand what is the information that we can get about different types of atoms from the periodic table. Now, most of you will have a copy of the periodic table either in one of your science books or one of your exercise books, or maybe your planners if you have a school planner. So rub this off, and we're going to have a quick look now at a periodic table. So I've got my periodic table here. Now, on my periodic table, first of all, we have a diagonal divide going across the periodic table there. Now, this diagonal divide here, which goes from boron to astatine, okay, this diagonal divide is extremely important because everything that is on the left-hand side of that diagonal divide is considered to be a metal. And the elements on the right-hand side of that diagonal divide, so all of these here, are non-metals. Okay, so that's the first important thing that we're looking at. Metals and non-metals. Okay, so for example, if your science teacher asks you to name two metals, all you have to do is look on your periodic table and choose any two things from this side. If your science teacher asks you to name two non-metals, you just look on this side of your periodic table and name any two elements from this side of the periodic table. Now, when we're looking at these, I'm talking about elements. Now, it's important that we're not getting elements confused with compounds. Okay, so an element is a substance that is only made up of one type of atom. So if I've got a substance and it only has lithium atoms in it, then it's an element. If it's got lithium joined to anything else, then it is not an element, it's a compound. Okay, so that's just a little bit of recap on what an element is. Now, when we're looking at the periodic table, okay, the periodic table is going to tell us about lots and lots and lots of different elements that exist to make up everything that we can feel, we can see, we can touch, we can smell. Okay, so everything is made up of atoms of these elements, either joined to the same type of element or joined to other types of atoms to make compounds. Everything around us is made up of atoms of these things on this periodic table joined together in some sort of way. Okay, now, first of all, it's important for us to understand how we recognize different elements. Okay, so we've got these symbols that scientists use for short instead of writing out the whole name of the elements all the time. Now, when we're looking at how these different atoms are joined together to make compounds, we can write them as formulas using these symbols. So, for example, instead of writing sodium, I would write a capital N and a lowercase a. If I wanted to write aluminium, I would write it as a symbol with a capital A and a lowercase l. If I was writing the symbol for chlorine, now I'm going to mention chlorine because a lot of time people get these wrong. Okay, it's a capital C and a lowercase l. Okay, that's the symbol for chlorine. It's important that we write the symbols correctly. Okay, now in terms of symbols for these particular elements, okay, if we are looking at writing symbols, okay, if the symbol for a particular element is one letter, okay, if it's one letter, it is always going to be a capital letter. Okay, so what I mean by that is, if we look at nitrogen, nitrogen has the chemical symbol N. Okay, but if you write it, it has to be written as a capital N. Okay, so nitrogen is a capital N. If you wrote the symbol for nitrogen as a lowercase n, that would be incorrect. Okay, so it's important that we understand the significance of the capital letter. The reason being, some of these symbols have two letters. Okay, so some symbols have two letters that make them up. And if we have something that has two letters, the first letter has to be a capital, but the second letter is always lowercase. So the second letter is never a capital. Okay, so for example, if we're writing chlorine, the correct symbol for chlorine is a capital C and a lowercase l. If you write a capital C and a capital L, that is incorrect. Okay. Now you might think, well, what's the significance of this? The significance of this is that this allows us to understand for particular molecules which elements make them up. Okay, so if we look at some different elements, so for example, if I looked at magnesium, I'm going to just move this to the side now. So if I looked at, I'm going to use my black pen, magnesium oxide, okay, I can tell that magnesium oxide, so we've got magnesium and oxygen, which makes magnesium oxide. I can tell that magnesium oxide has two different elements that make it up. I have my magnesium, which is my Mg, and I have, starts with a capital, then a lowercase, and then I have my oxygen, my capital O, which is my second element there. So if I was asked how many elements are there in magnesium oxide, my answer would be it has two different elements that make it up. Now, if we look at how this could be different, so for example, if I write carbon monoxide, okay, this here is carbon, capital C, joined to oxygen. Now this isn't a particularly nice molecule here. Carbon monoxide is a poisonous gas. You can't see it, you can't smell it, but it is toxic, so not a very nice molecule there. That's carbon monoxide. Now that's capital C, so I know it's carbon. That's a capital O, so I know it's oxygen. So I know I've got two elements there. However, if I had written a capital C and a small o, okay, that there is something different. This, if you look here, capital C and a lowercase o, this is one element, and this is the symbol for cobalt. So can you see how this is very different to this? That's carbon monoxide, two capital letters, telling me I have two elements making this up. This is just one element, capital C, lowercase o. So this on my periodic table is here, and this is cobalt. Whereas this is carbon, capital C there, joined with oxygen, capital O there. Okay, so it is very important that we actually write our symbols correctly when we're writing them down for science. Now, what I'm going to ask you to do, just so that we can make sure you've got the hang of this, is I am going to rub this off, and I'm going to ask you to have a go at writing down. So this is where you need your pen and your piece of paper. So I would like you to write down for each of these how many different elements we have in each of these. Okay, so I'm just going to move that down slightly so we can see that properly, and I will give you about 5 minutes to have a go at this. Okay, lovely. So now let's go through these. Now, if we look at this first one here, okay, remember we're looking for capital letters as the start of a new element. So I've got a capital H, that's one element. I've got a capital C and a lowercase l. So that lowercase l goes with that capital C. So here we've got one element which is H and another element which is Cl. So we have two elements in this first molecule here. H is one element, Cl is my second element. So that means altogether I have two elements which make up my HCl. Then for my second one here, I've got an N and a lowercase a. So remember, if there's a lowercase letter in front of the capital, it goes with it. So that's Na, which is sodium. And then again, I've got a lowercase l with my capital C, so they go together, Cl. So again, I have two elements in this second molecule. Then if I have a look at my third molecule here, now this one is a little bit more tricky because it's got a number in it. Now what this means is I've got my M with a lowercase g, so Mg is one element. Okay, now what I've got here is I've got Cl, capital C with a lowercase l, so that's my second element, and that little 2 in the bottom right hand corner means I have two chlorine atoms in this molecule. So I have one magnesium, but it's joined to two chlorines. Okay, the way that this works is if you only have one element, you don't have to write a number after it. So when there's no number after it, that means you have one. So I can see I've got one magnesium there. There's no number after the Na there. That means I've got one sodium. No number there. That means I've got one chlorine. No number there, one hydrogen. No number there, one chlorine there. Okay, sorry, that shouldn't be a 2 there. I've got, now that 2 there means I've got two chlorines joined to one magnesium. Now this is one element. Although I've got two atoms of chlorine, it's still one element. So those two chlorines are not two different elements. So if I'm thinking about how many elements do I have, that means here I still have two elements. Now, if I was asked how many atoms do I have, then I would say I've got 1, 2, 3 atoms. Okay, but if I'm asked how many elements do I have magnesium and I have chlorine, so I have 2 elements. Okay, now if we look at sodium here, I've got sodium, but the 2 means I've got 2 sodiums. So in this molecule, I've got 2 sodiums. Then I've got a capital O, which means I've also got oxygen. No number after it, so that means I have 1. So again, I've got sodium element and oxygen element. So I have 2 elements. In terms of atoms, I have 3 atoms altogether, but 2 elements. Now, if I look at this next one, I've got K, which is potassium, and then I have a capital I, which is iodine. No number in front of the capital K, so I've got 1 potassium atom. No number in front of the I, so I have 1 iodine atom. So I've got 2 elements altogether for this one, but also 2 atoms. Now, if I look at my next one, I have a capital C and an A. So a capital C and an A, they go together, lowercase a, capital C. No number in front of the lowercase a, so that means I've got one CA. Then I have a capital C. No number in front of my capital C, so I only have one. And then I have a capital O, but then I've got 3 in front of the capital O, which means in this molecule I've got 3 oxygens. So I've got 1 calcium, which is the Ca. I've got 1 carbon, which is the C. And then I've got 3 oxygens, which is the O3. So in terms of how many different elements, I have 1, 2, 3 different elements. But if the question was changed and I was asked how many atoms are there in this molecule, then I would say 1, 2, 3, 4, 5 atoms in that molecule. Okay. Now, if we look at this one, we have a capital C and 2 capital O's. So again, 2 elements and 3 atoms altogether. And if I look at this molecule here, H2, so H, which is my hydrogen, but because I've got 2 of them, that means I've got 2 hydrogens joined to 1 O. So again, we're looking at 2 elements. Oh, paper's gone off a little bit there. 2 elements, but 3 atoms altogether. And this one is quite a common molecule. This is H2O, which is water. Okay, and then the next one, N2. And what that means is I have 2 nitrogens. Okay, 2 nitrogens, they're still the same thing, which means although I've got 2 atoms, I have 1 element. Okay, now I'm just going to say what these are. I don't think I've got quite enough room to write at the bottom there, but if we look here, Al2, so I've got an Al and an Al, and then I've got O3, which means 3 O's, 1, 2, 3, so 2 elements altogether, and 1, 2, 3, 4, 5 atoms altogether. Then for this next one, H2, which means I have a H and another H. Okay, so 1 element but 2 atoms. And then lastly, over here, I've got H2SO4. So H2 means I have 2 H's. Now that's a capital S with no lowercase in front of it. So that S is by itself, which means I've got 1 S, which is 1 sulfur. And then I've got 4 with my oxygen. So that means I have 4 oxygens. So altogether, I've got 1, 2, 3 elements. And in this particular molecule, it's made up of 1, 2, 3, 4, 5, 6, 7 atoms. Okay, now, as we've gone through these, what you might realise is to work out how many elements you have in a particular molecule, all you need to do, if you've written out the elements symbols correctly, is see how many capital letters you have. So if we look here, I've got 1, 2 capital letters because a different element always begins with a capital letter. Okay, so I've got 2 elements and 2 capital letters. I've got N as a capital, the A goes with it. C as a capital, the L goes with it. So here I've got 2 capital letters, 2 elements, because every element begins with a capital letter. Capital M, G goes with it because it's lowercase, and again capital C, lowercase L, so 2 capitals and 2 there. Let's just move on quickly and have a quick look at this one. So if we look here, capital C, A goes with it. Capital C, and a capital O. So we've got 1, 2, 3 capital letters, 3 elements. Okay, so if you're not sure whether you've started writing a new element or not, you've got to remember that elements always begin with a capital letter. And if they have 2 letters, the second letter is always lowercase.